Hi, hello everyone. So this is just a quick extra video on statistics. Um, Statistics is a very popular question, and the maths in it is pretty rudimentary, but the interpretation is what's key to this one. Okay, so let's have a look at it. In a recent flood, 3,000 computers. Okay, an insurance assessor wants to estimate the damage, takes a random sample of 140 computers and finds that 34 of them are damaged. Okay, find a 95% confidence interval for the proportion of the computers. Proportion, there's your key there. Okay, so let's have a look at them. Okay, so we have 140. We have 95% confidence interval. So that, to me, I'm redeemable proportions. To me, that signifies we're using our p hat formula. Okay, so that's usually p hat plus or minus 1.96, the square root of p hat minus, or sorry, bracket 1 minus p hat all over n. So that we have everything we need. We have a p hat, I can get it from 34 over 140. Do I have an n? That's 140. It's not the 3000. Okay, that's not the 3000. Be careful of that. A sample of 140, that's your n. Okay, so let's pop it in and we'll do it. So proportion wise, let's get out our friend Mr. Calculator, because he's going to do a lot of the hard lifting for me on this one. Mode 1. Okay, so we're going to have proportion wise, we got 34 over 140. That's 17 over 70. Plus or minus. Now, let's do this. I'm going to keep that in the memory. That's 17 over 70 because it's going to be handy. So 1.96 by the square root of a fraction, and it's the answer. It's the answer bracket 1 minus the answer over, what is it, 140. Okay, so it's let me see, it's going to be 0.010. So it's going to be 0.0710. So that's not our answer. We're not going to give it into that form. We're going to add that to that and then take that away, and that's going to be our interval. Okay, so that means our probability is going to be less than, I'm going to add that, plus 17 over 9 over 70, 0.3138, 3139, 0.3139, and it's going to be greater than minus, take it away. Thank God for these calculators. Take it away. I'll take it away again. 17 over 70 minus, so 0.1718. Okay, or the probability is less than 31.39% and greater than 17.18%. Okay, so there's your confidence interval. Done. Right, next bit of the question. Let's try and find it. I have it here somewhere. Hope I haven't thrown it out. Just bear with me a second. So many of these printed off. Very professional, but then just find these. Where are they? There was another bit to that question. Tell me it's gone. Okay, I think it's gone, but if I remember correctly, oh God, what was the other bit of that question? Yeah, the other bit of that question, if I remember correctly, was find the 95% confidence interval. So for the number of computers. So that's the confidence interval for the proportion, but find the actual number. So this is where you take each of those numbers and multiply it by 3,000. So the probability it's going to be less than 3,000 multiplied by 0.3139, less than 3,000 multiplied by 0.1718. I think that's what it was. So it's just a bit of a weird one. It's just the way it was phrased. Just the printer, you can see it, the printer cut off the bottom of the page. It's a bit annoying. But anyway, so 3,000 multiplied by 0.1718, you're talking about 515 and 0.3139. You're talking about 942. So somewhere between 515 and 342 computers in reality. That's what we're actually dealing with. Okay. Yeah, that's what we're dealing with there. And let's see what's our next one. Okay. Question somewhere. Here we go. Found it. Typical. So that was it. Find the confidence interval for the actual number. So that's what I've done there. Found it. So that was it done. So the last bit of that question then is, this where it gets tricky. The assessor wishes to halve the margin error in part 1. Okay. So assuming everything else is kept the same, how is he going to do it? Okay. So if the p-hats, that means the p-hat is going to remain unchanged. So he just wants to halve the error he's getting. So what is the error? The error is going to be, well, the error is our formula that we just used at the very start. So he wants this to happen. Okay. He wants 1.96 square root of p-hat on 1 minus p-hat over n to be equal to half 1.96 square root of p-hat on 1 minus p-hat over n. So he wants these two to equate, and what we want to do is we want to put in our numbers here and get an n value. Now, if you look very carefully, these all cancel. All of that and all of that cancels. So you're really just left with 1 over, and the root kind of cancels as well. So you're going to get 1, that's 1, and you still have a root n on this side, okay? And on this side, you're going to get a half of 1 over a root n on this side, okay? So this is the side we're going to pop our numbers into. So what number are we putting into 140? That's the number we have. So 1 over root n is equal to half 1 over square root of 140. So that means we're going to, let's see, double both sides, I suppose, square both sides. Okay, so that's going to be 1 over n equal to 1/4 1 over 140. So we're going to have to work this one out. That's what, 4 14s is 560. So n is 560. So you're going to need 560 in order to half the number. Okay, so that's a bit of a tricky one. Okay, but let's read it before we move on. He wishes to half the margin of error. So what they're really asking you today is, do you understand what the formula is for the margin of error? And from our previous one, the margin of error is just our p-hat formula. Because look, it's plus or minus a margin of error. So you're just making one side equal to the other one and working it out. Okay, so next bit. The next bit is lactase dehydrogenase is an enzyme found in nearly all living cells. Measuring LDH levels can be important in monitoring the effectiveness of certain medical treatments. For a particular group of patients in a research study, the distribution of LDH was normal. Okay, so we're using normal with a mean, so we have a mean and a standard deviation. Find the proportion of the levels between 200 and 240. So this is our standard Z, okay? So remember, Z is equal to X minus mu over sigma. Why are we using this version of Z? Because we have a single sample with one mean mentioned. We don't have two mean mentioned, which would give us the alternate version of the Z formula. Okay, so we have everything we need here. Okay, so we're going to pop it in. Let's get the Z for 200. So the Z for 200 is going to be over 15, which is 210. We're looking at minus 2/3. So minus 0.67. We're not because we're looking this up in the log tables. We're going to have to be a bit conservative. Minus 0.67. It's minus 0.66, but listen, it's minus 0.67. Let's get to 201. Sorry, to 241. I'm sure you can already tell that one. That's 30 over 15. Don't even have to do that. That's 2. So the proportion is going to lie somewhere between 2 and negative 0.67. Okay, so what we really want is we want to get the probability that it's less than 2. Okay, and we also want the probability that it's greater than that, but that's the same as saying 1 minus the probability that it's less than 0.67. So that's the one we're going to look up on the log tables. Okay, we look up 2, we look up 0.67 and take 1 from it, and then in between those two answers we have our actual answer. So the probability of it being 2, okay, I'm just going to look it up here on my computer. Probability of it being 2 is 0.9772, and the probability that it is 0.67 is 0.7486. So 1 minus 0.7486 is 0.2514. 0.2514. So it's 0.9772 minus 0.2514, which is 0.7258. And that's the probability. Sorry, that's the proportion that lies between, probably I keep saying, that's the proportion that lies between it. Okay, so that's a nice standard one. Now, reduced levels of LDH usually indicate that medical treatments are working. Find the lower quartile. Ooh, this is one that wouldn't have been happened before. Okay, so you want to find the lower quartile. Okay, so the lower quartile is going to be the 25. It's the 0.25 proportion. It's the bottom, 25% of people. Okay, so we need to find the Z that represents that. Okay, so the Z that represents that, let me just look it up. We're looking at 0.675, but it's negative. So minus 0.675, that's going to be our Z. Let's make that equal to X minus mu over sigma. Let's put in everything we want and we'll find the X. So that's minus 0.675 is equal to X minus 210 over 15. Okay, so this is going to generate a positive, and that's the whole point. Okay. Let me do 15 by minus 0.675, and then add 210, and we're left with 199,875. Okay, so well, find the lower quartile of LDH patients. There's the lower quartile. Okay, found. Okay, last bit. 1 month later, 100 of these patients were randomly selected and underwent further testing. It was found that their LDH were normally distributed again with a mean of 208 and the same standard deviation. So the same standard deviation was 15. Put that in there so I don't have to look back up. Using the sample mean. Find a 95% confidence interval. Okay, it's a sample mean. Here we go. So the sample mean is going to be plus or minus, what is it, 1.96 sigma over root n. Okay, there we have this one. Now, see, look, they mentioned it. So that's why it's important. So what do we got? We've got 208 plus or minus 1.96, 15 over the square root of 100. So we've got a 95% confidence interval. Let's see, it's going to be 208 plus 1.96 bracket 15 over 10, which is 210.94. I'm just going to minus it. Save me all that hassle. 205.06. So there you have it. There's your 95% confidence interval based on the sample mean. Okay, so I hope that gives you a little help. Now, there's more. There's more. So we're going to hypothesis test that this wasn't changed. So let's put down our clearly state. There's our null, is the mean is 200. That hasn't changed. And the alternate is the mean is not 210 and has changed. Simple as that. Okay, so we've just worked out a confidence interval. Say from part, the confidence interval is 205.06 to 210.94. I should put in the 95% confidence interval. Okay. As 210 lies in the 95% confidence interval. Well, I'm going to use my phrasing. We fail to reject the H0. Okay. Now, as some of you might be eyeballing already, and I've already talked to you about this before, they're going to make you do the p-value anyway. So you could have used your p-value there. But listen, you know, I did it this way. You know, I'm not going to be shamed into it. So let's work out our p-value. So how do we work out our p-value? We use the extended Z rule, don't we? So this is your Z is equal to X bar minus mu over sigma over root n. Okay, so let's put in all our numbers. We've got X bar, which is 208 minus 210 over 15 over root 100. And that gives us 208 minus 210 divided by 15 over 10 minus 1 1/3 minus 4 of 3. Okay, now what do we do to this number? Okay, I hear you ask. Well, you always 2 times 1 minus this Z, and if that is greater than 1.5, greater than 0.05, and if it's less, so let's work it out. If it's greater than 1.5, it must be inside. So let's have a look at it. So let's get the Z for this one. Let's see, it's going to be 0.9083, sorry, 9082, I think, yeah. So 1 minus 0.9082 gives me, so that's 1 minus 0.9082. I'm going to double it. Got equals 0.1836. So that's greater than 0.05, as the p-value is greater than 0.05. we do not reject, as the lower the p-value, the stronger the rejection below 0.05. Okay, so hope that helps clear that one up. Right, on to another one. So, sorry, get this slide back. We're going to salmon now. Salmon, would you believe? So, salmon fishing in the Yemen. I think that's a movie, isn't it? Somewhere I saw. Your man, I can't remember his name. Oh, Ewan McGregor. Yeah, that's right. Right. So let's have a gander at this one. Now, this one, I remember this one. This is 2021, so this is probably the last proper year. It's a bit of a toughie. Right. Farm salmon has harvested when they go to a certain length. The lengths are normally distributed with a mean and standard deviation. This is the Z rule straight away. So let's just dive right into it. So Z is equal to X minus mu over sigma. So what do we got? That's equal to 35 minus 32.8 over 2.4. Now, 35 minus 32.8 divided by 2.4 is 0.91666, so 1.92. Okay, 0.92, but we want greater than 35. So that means in terms that we want this area up here, so it's going to be a 1 minus the probability that is less than 0.92, whatever that is. So look up 0.92, 0.8211, 0.8212, sorry. That's what we have. 1 minus 0.8212, 17.88% or 0.1788 as a proportion. Okay. Now, on further analysis, it was determined that 60% of the salmon produced in the farm have lengths between 3.8 and T. Find the value at T. So this is the same thing again, except we're just kind of working our way into it. So always visualize these if it helps you. Okay, so we have 60%, and that's represented by between 3.18 and T. There's T, and there's 31.8, sorry. So just looking at the mean, what was the mean again? It was 32. So we've one less than the mean, and obviously we're hoping to have something bigger than the mean, I'm assuming. So let's try and work out our two numbers anyway, at least. So let's get the 31.8, okay, because we need that one, okay? So the Z for 31.8 is going to be 31.8 minus 32.8 over 2.4, which is going to be 1 over 2.4, which is minus 0.42, which makes sense. It's less than the mean. Okay, that makes sense. And the probability, the other one, Z of T, is going to be T minus 32.8 over 2.4. Okay, so let's try and work this out. This one is going to be 1 minus. So let's work out that fella's one. Okay, so that's 1 minus the probability of 0.42. Probability of 0.42 is 0.6628. So that's 1 minus 0.6628 will give me the Z score I need, or give me the number I need for this. So 1 minus 0.6628 is 0.3372. So that's what this side, 0.3372. That's on this side here. That's where that represents. Okay. Now, the other one is obviously going to be 0.3372. So we're going to have to work out, let's think of this other one. So it has to be all that backwards. So it must be the 0.3372 and the 60 together. So 0.3372 plus the 0.6 must be the t-value. Okay, because to get the t-value, you take t, which is the whole way back, from this, which is the whole way back. So to add them together, you must get the full amount. Does that make sense to you? So watch. This plus this must be all the way back. But I just worked out this way back, but I know it's 60% between the two of them. So add them together is 0.9372. So we need to work out what 0.9372 will give us on our Z scores. And 0.9372 works out as 1.53, I think. So 1.53 is going to be equal to t minus 32.8 over 2.4. 1.53 by 2.4 plus 32.8, 36.47 centimeters. Okay. So quickly go through that one again. It's a bit more difficult. You're given an interval. Part one of them is missing, so you have to kind of backtrack your way. Get the Z score for this, so you're getting that area back there. Add it to the area you know between the two, which is 60%, and then that gives you the point to how to generate the Z score for that, and then find the unknown value from it. So it's a nice one, actually. It's a bit of a tricky one. It's probably one to make people think. Right, next bit of the question. Oh, hypothesis testing. Okay. So 250, 33, same standard deviation as before, which was 2.4. Write that in there. Hypothesis testing. They're going to ask us for the p-value down here, but listen, you know what? Let's just do it old school anyway. Let's find the Z score and show that Z score is greater than or less than 1.96. That one. We'll go with that one. So let's get our Z, x bar minus mu over sigma over root n. So that's going to be 33.2 minus 32.8 over 2.4 over the root of 250. So what is that? That is 2.64. So, oh, sorry, it's a hypothesis testing. So really, should I start with the H0? H0 is that the mean is 32.8, and H1 is that the mean is not equal to 32.8. Okay. So as at 95% confidence level. So obviously at the 95% confidence level, Z score is 1.96. Okay. As 2.64 is greater than 1.96, we can reject the null hypothesis. So we can reject it because it's outside. Okay, we can only accept it if it's inside minus 1.96 to plus 1.96. We can only accept it in that area. And anything outside that area that's generated as Z score, we reject. So now we do our p-value. But listen, we've done all the kind of hassle on the p-value. Okay, you could have done a confidence interval there as well. But listen, you know, much for muchness. You're going to use this value anyway. That's the reality of it. So we've already worked this out. So a p-value for this one is, you know, let's try and think of it. Find the p-value of the test and explain what this means. Okay, we know that if a p-value is less than 0.05 or greater than 0.05, you know, if it's less than 0.05, it's a strong rejection. And the further lower than 0.05, the better the rejection. So let's work it out. Okay, so let's work out the Z score of 2.64. Okay, so it's 2 times the probability that of 1 minus a Z score of 2.64. So that's what we're really looking for. Okay, so let's work this out. Z score of of 2.64 is 2.64 goes to a probability of 0.0041. So 2 times, sorry, it's 0.994. Sorry, I just have to do this in the calculator. That's when I take it away from 1. It's actually 0.9959. 0.9959. So when I take 1 minus 0.9959, and I can get in 0.0041, and I'm going to double it. So 2 bracket 1 minus 0.9959 is 0.0082. That's my p-value, which is less than 0.05. As the p-value is a lot lower than 0.05, we can have confidence in rejecting the null hypothesis. Okay, it's a very strong rejection. Okay, right. Now, farmed out salmon, farmed trout are produced in freshwater, in particular for the length 90 or no distributed 97 have lengths of less than, and 67 have find the mean and 78. Okay. So here they're giving us lots. The lengths of the trout are new, with 97.5 of them having a length less than 34.2, and 67 of them having lengths greater than. So, you know, in terms of, let's take this value here, the first one, okay? So 95% of them, 97.5% of them are this way, okay? So let's try and work that one out, okay? Let's put in what we can figure out on this one. Let me think. 67 of them have a length greater than, 67 is an important number, because 67 is 1.96, okay? So that's for sure. So let's think. Let's get the let's get the Z value for 97.5. Okay, 97.5 gives you a or a Z value of 1.96 actually. Okay, so let's put that into our formula. 1.96 is going to be equal to 34.2 minus mu over 1.96, or sorry, over sigma. So that's one of them. Okay, now let's work out the other one at the other end. So that's at the top end. Okay, at the bottom end, obviously it's going to be a negative because it's going to be less than. Okay, so at the bottom end, let's try and work this out. We have 0.67 from the Z tables. Let's say 0.67 on the Z tables is 0.44. So, and it's going to be negative 0.44. So you're going to have negative 0.44 equal to 26.6 minus mu over sigma. Okay, so we have two formulas. Now, the logic here is we need to get rid of one of these variables in order to make it work. So this is not easy thing to do, but manipulate this formula around to get sigma, sub it in there, so you're only solving for mu and then sub it back in. That's really what you're looking at. Okay, so let's try and rearrange this one. Sigma, cross multiply and then divide across by minus 0.44. That's 26.6 minus mu over minus 0.44. Okay, so that is a formula. If we substitute that formula, I'm trying to think, should I rearrange? If I sigma the other one as well, would that make it a bit better? Yeah, I'm wondering. Yeah, I think I'll do that. I'm actually going to I could substitute that in, but I'm just looking there, and that's just going to be hazy. If I just rearrange this in terms of sigma, I can just make the two sigmas equal to each other. So I think I'll go that way. So same thing here. That's going to be, sigma is going to be 34.2 minus mu over 1.96. So now I can just make the two of them each equal to each other, which I'm going to do right here. So 34.2 minus mu over 1.96 is equal to 20. I'm going to change the signs on this one. Minus 26.6 plus mu over 0.44. I don't like having the minuses on the bottom, so you have to keep them on the top. So cross multiply. So that's, I'm going to solve this one then. It's going to be a bit of hassle, but that's 0.44 times 34.2 minus mu equal to 1.96 on minus 26.6 plus mu. So 34.2 by 0.44 is 15.048 minus 0.44 mu equal to 1.96 by 26.6 minus 52.136 plus 1.96 mu. Bring the mu's to one side. So it's 1.96 plus 0.44, which is 2.4 mu, equal to, add those two, you have 15.08, 0.048 15.048 plus 52.136 divided by 2.4, and we're looking at 27.99. 27.99. So if mu is 27.99, I'm just going to pop it back in and find sigma. I'll just put it into the easier of the two formulas. Okay, so 34 point minus the answer divided by 1.96, and we're getting a sigma of 3.17. Sigma of 3.17. Okay, now that's a bit of a toughie. All it's